All right, we're going to go over some more probability rules past just the basic ones today. So some of these learning targets we've hit, we're kind of starting with 5.2 lesson and then going to get through the rest of that, and we'll start on 5.3. So here's the things we haven't hit yet. We're going to use a two-way table or a Venn diagram to model a chance process versus just a regular table, and calculate probabilities involving two events based on that. We're going to do the general addition rule to calculate probabilities. Last time we did the addition rule for mutually exclusive events, and now we'll talk about even events that are not mutually exclusive. And then we're also going to talk about calculating and interpreting conditional probabilities. So there was an extra piece of the information that was given, and then determine whether two events are independent using, again, that Venn diagram or two-way table. So to start out with, I have given you, since you weren't able to be in class to calculate this, I have given you fake data to talk about the people who can do the evil raising of one eyebrow and who can roll their tongue, so taco tongue. And then the two-way table represents kind of where they fall in terms of the yes or the no for those ones. We had 30 total people in this fake situation. Go ahead and copy down those numbers, and what I want you to do is see what you know. Okay, so I want you to try to answer questions 1 all the way through 7. See what you know just by intuition to be able to answer these probability questions, and then we're going to go over them and talk about how they work. Okay, so pause the video and try those for me. Okay, first thing I want to show you is kind of how the Venn diagram works. The yes taco tongue is everybody who said yes to taco tongue, so there should be 20 total in this whole circle. However, there are two pieces to this circle. The people who are yes taco tongue only, and then there are people who are yes taco tongue but also fall in the yes to evil eyebrow. So the double intersection of both was the 15 here, and there were only 5 who could not do the evil eyebrow as well. Then on the other side, this whole circle is the yes evil eyebrow, so that's this entire column. We've taken care of the 15, there are 3 people left over. And if you'll notice, if you add these 3 together, we've got 23. There are 7 people who we haven't talked about yet. Those 7 people are the double no's, the neither. Okay, so this represents our neither. Okay, here in the middle is our both. And then on the sides is our only. So it's really important when you draw a Venn diagram, you don't put the entire yes taco tongue, 20 people, you don't put it just to the side. You want to separate it out into their different sections based on the context you were given. Okay, so checking some of this work here. You should have gotten, for the and, the 15 out of 30, and reducing it. And then for the yes to taco tongue, but no evil eyebrow, that's 5 over 30. Yes evil eyebrow and no taco tongue was the 3 out of 30, and then that last one was 7 out of 30. When we talk about probabilities, you can write them as reduced fractions, decimals, or percents. My favorite's going to be a decimal. Because they're more easy to understand versus a fraction, but could end up reducing to different denominators, so they're not as easy to compare. Now, I want to remind you of something that we talked about earlier this year with relative frequency. We had joint relative frequencies. This is the same thing. Okay, if you have 2 conditions you're working with, an and an intersection, that was considered joint. Okay, for this chapter, it's not necessary for you to have that like vocab memorized, but I'm just relating it back to what we've talked about already. Okay. This next section, they were marginal probabilities relating to your marginal relative frequencies because they corresponded to a single row or a single column on your two-way table. So the yes evil eyebrow was the total 18 here, or the total 18 in this circle here for the Venn diagram. The no evil eyebrow, same thing. And then when you put that yes evil eyebrow or no evil eyebrow together, you get 1. So this is what we did last class, is you can just add those probabilities together because they were mutually exclusive. Okay, there's no overlap. You cannot be yes to evil eyebrow and no to evil eyebrow at the same time. Okay, so no intersection is not overlapping, so they would be mutually exclusive. Okay, so our rule for that, the addition rule, was if you have an or situation, you could just add them. Okay, so this or is union. Okay, so we're talking about two events, A or B, and you just add them. Now, one other thing that these are happening is complementary. So these are mutually exclusive events who also hit every possibility. So there's a possibility of yes, evil eyebrow, no evil eyebrow. Those are the only options. Now I want to point out that is not the same thing that's happening in this diagram here, because this was taco tongue versus evil eyebrow. So this is only in the realm of evil eyebrow, okay? But they were complementary because they were mutually exclusive and their probabilities add to 1. All right, these ones down here, yes, taco tongue, again, were marginal probabilities, 20 out of 30 for that one and 18 out of 30 for your evil eyebrow. These ones are not mutually exclusive because yes, taco tongue and yes, evil eyebrow overlap. So we could take the 20 total from the first circle and the 18 total over here and subtract off the intersection. Okay, or you can go up to the table, and this is what I usually like to do if you have a two-way table, is your taco tongue, yes, is here, and then your yes, evil eyebrow is here. You're just going to count the 15 plus the 3 plus the 5 and put it over the total. You don't have to count that 15 twice originally, and if you don't count it twice, there's no need to subtract. So sometimes just listing it out and counting will get you there a little bit faster. So that's what I put here, that the tables or the Venn diagrams are going to make this problem and the next few more intuitive, where you don't necessarily have to know any of these formulas. Okay, so here's your general addition rule. When you don't have mutually exclusive events, you still take your probability of A plus probability of B, like up here, but you subtract off this intersection. So this thing where we said it was both was also the intersection of A and B. Okay, so when we see that upside down U, that's intersect, and we're using that for situations that are and. Okay, so that's our both. We subtract that off and it gives us the union, or the or. Okay, given is new here. So given is our conditional probability. And that is a vocab that you'll want to know. Okay, but when we deal with our conditional probability, that's going to change our total value. Okay, so I want you to make a note of that. Whatever they tell you is the given is going to be our new total rather than the grand total of the 30 students. So we're saying giving a person was evil eyebrow. So we are only looking at these 18 people. From those 18 people, we want the probability that we're yes taco, so that's our 15 out of 18. Okay? Similarly, down here, it says given that they were no evil eyebrow, so given that we are looking at these 12 people, from there we want to look at yes taco tongue, that's the 5 out of those ones, and calculate that probability based on that. It did ask us for a fraction, a decimal, and a percent, so make sure you have all three of those. And I want to point out what this looks like in terms of what you'll see on your formula card. Okay? So this bar means given for us. So if you see that symbol, and you're going to see it on the next problem on the next page here, given, or number 8, okay, but that says A given B. So here's how the formula looks. You can take the probability of the intersection, so A and B happening, over the probability of B. I'm going to start with the bottom when we explain this. So the first thing we decided here was evil eyebrow, the total. So the probability of yes, evil eyebrow, from back what we did with marginal probabilities, was 18 out of 30. So there's my denominator. Okay, then on top, I'm restricting it down to only talking about evil eyebrow. So on top, when I talk about the probability of A, I want to make sure I only am in that column, so that's the A and B both happening, the yes taco tongue and the yes evil eyebrow, the 15. So the probability of that was 15 out of 30. But when you have a fraction over a fraction, multiplying by the reciprocal cancels out those 30s, leaving you with the 15 over 18. And it was much easier with the two-way table to just look at that one column and calculate the probability from there. Okay, so your note card helps you if you get stuck, but it really relies on you understanding all of those symbols. Okay. All right, so then on the bottom, we're going to say no. Let's talk about independent for a little bit here. It says two events are independent if knowing whether or not one event has occurred does not change the probability. Okay, in plain language, that just means the probability of yes taco tongue would look the same no matter the answer to evil eyebrow. Okay, so if you said yes evil eyebrow, if you said no evil eyebrow, taco tongue would be the exact same probability. So we calculated that up here. We said here is a yes evil eyebrow, here's a no evil eyebrow. The probability of yes taco tongue was not the same. So this one's a no. People who can evil eyebrow are more likely to be able to taco tongue than those who cannot. Those were the calculations we made. In general, you can look at a lot of different things. You could look at just the probability of A. Is that equal to the probability of A given B? Because if so, independent. Is the probability of A equal to the probability of A given not B? Or the complement? Okay, this is your independent test. And when you have a table, you can do it pretty quickly because you're just seeing, are these proportions the same all the way through? Is this 15 over 18 the same as 5 over 12? Is it the same as 20 over 30? If it's not, then it's not independent. Okay? So I'm going to have you now pretend these proportions are, oh no, this one's just consider the fake data to practice now that we know what this symbol looks like. So I'm going to have you pause the video and try number 8 here for me and see if you can determine independence based on what we just talked about. Okay, for this one was another no. Again, because our proportions do not look the same all the way through. We had 90 over 100 versus 150 over 200 or 240 over 300. These were not the same. Being able to evil eyebrow made taco tongue more likely. Okay, 0.9 was the standard, but if you had yes to evil eyebrow, we had 90%, and then if you had no evil eyebrow, it was only 75. Okay, so here's your average, and then higher if you had that evil eyebrow. How you word your justification is very important to me, so you don't have to necessarily start with the evil eyebrow, but you should involve some sort of calculations. You can use our symbols here. We can say the probability of yes taco tongue was not equal to the probability of yes taco tongue given yes evil eyebrow, and it's not equal to the probability of yes taco tongue given no evil eyebrow. Okay, those should match. Alright, I want you to now consider what it would look like if we did have an independent test. Okay, so if we want these three proportions to look the same all the way through, I need a 1 to 2 to 3 ratio to get to 240 to get to 60. Okay, so what you can do here is decide here, this is a factor of 5. Okay, so we're dividing by a factor of 5. Same thing here. You can use your patterns. This is 1, 2 times 3. So if there's 3 total, you can do here dividing by 3, and that's 80. So 80 and then twice that is 160. But we're filling this out based on our pattern. And then this one was 20 and 40. Again, because there's a factor of 3 total, you can divide that. There's 20 and double it to get to the 40 of independents. So from here, take a minute to calculate 10 and 11 for me based on that filled out table. Okay, hopefully you got that they were 80% all the way through, written as a fraction, a decimal, and percent. And you'll notice that these problems, all the probabilities are the same with independent, whereas that is not true for dependent or not independent situations. Okay, so we've talked about a lot of these notes already, so I'm not going to spend a whole long time on these. I do want to add symbols so you're familiar with seeing it. Remember, or is union, and is intersect. Conditional probability, this bar means given for us. Again, this and is intersection. Okay, they have that here, and that always represents the both. Last thing here that's new is this one up here. That's the complement, but we read it as not. So that says not B. So the probability of A given B is equal to A given not B, and just the regular A. Okay, so last thing we're going to do is talk about some symbols here, and then we'll practice. So with this, we already showed some of this, but let's talk in general. All of these circles together is going to be our union. Intersection is just going to be what's in the middle. That's the one we've talked about already. And the complement is everything outside. So everything except for A. Not A would be outside of the Venn circle. Similarly, if you had a double situation, this right here outside would be the neither. Okay, or the not A or B. Alright, I want you to try the questions on the check for understanding, both problem number 1 and number 2. And when you're done, come back to the video and we'll talk through them. Okay, first one here. Hopefully you got that OC is not preferring to pull the toilet paper over the roll. Okay, so something like the probability for that P of choosing a student who does not prefer. Okay, and that was 46 out of the 116 as a decimal there. I do want you to, if you can write it exactly, do. So if this was a repeating 6, please write it like that for me. Then this one, or, why it didn't just equal adding them, that's because over the roll and replace when empty are not mutually exclusive. Or you could say there were people who did both. Okay, that means we have to subtract off that intersection. Or remember, you can just add up the individual ones here. So you can just take the 58 plus the 12 plus the 24 to get to that 94 without having that extra subtract. Okay, there's your Venn diagram. And then hopefully you got this RC does not replace the roll. And even better if you have that symbol, intersect O. 12 out of 16 there. Again, if you have a repeating decimal, please write it that way. Okay, this one, I do want to talk about some interpretation things that I care about. So check out how I wrote this first one. It's really important to me that you interpret probability in this way. I'm saying there's a 40% chance that a randomly selected mother surveyed in 1976 had 4+ children. Okay, when we talk about probability, we're not saying there's a 40% chance that this person had 4 children or not. They either had 4 or more children or they didn't. We're saying when we randomly select from all the mothers, there's a 40% chance that the one that we selected was that person who had 4+ children. Okay, so I want you to add that randomly selected in your sentence when you're interpreting for me. Okay, then we had given this one, remember, changes our total for both of these, so be careful and make sure you're calculating that correctly. And based on that, we are saying no, because these were not equal, it was more likely that a person chosen in 1976 had 4 more children than that other year. Okay, because of that, they are not independent of that.